Hello everybody, welcome back to High School Tutoring. I'm your host Manny, and today we're going to be learning about forces incline planes. So incline planes are just representing kind of like a horizontal value but at an angle. So that's kind of what I'm going to be explaining in just a moment. So obviously we have an incline, which is like just something raised at an angle. It's kind of, you can see on both here and here we have an incline to represent what the object's on. So as you can see, we have our object obviously, and we have a value there and stuff like that. So what we're looking at, what's pretty weird is you can see that f of g is still going directly downward. So there's something there. Here's the idea that we have. So if fg, since it's going downward but it's not directly affecting the actual surface, since it's not just a direct horizontal surface, this f of gravity is still pushing it down, which also means, as you can see here, we have a value moving it to the left and a value moving it down. So you can see with this incline, we look at Fn, and the normal force here, it's perpendicular to this value and not the horizontal as we've seen before. A normal force is perpendicular to the actual surface value that is being applied to. So you can see this inclined plane is the actual surface, so Fn will be perpendicular to that surface. So that's weird, and that rule doesn't apply to FG because FG is directly downwards anyway. So if we're looking at this inclined plane here, you can see we need a value that obviously makes it like this because Fn has to be on a force that's completely opposite of it, obviously. So that's where we get Fg cosine theta, where if we look at it, we see we have another triangle here. We make it into its components. This is our horizontal, and this is our vertical, and this is this is the theta value. That means that this is adjacent. Or well, actually no, this is this is our adjacent and this is our opposite. So that means that we have cosine here because it's adjacent over hypotenuse, and then we have sine here because it's opposite over hypotenuse for sine, and that's why we have mg sine theta and mg cosine theta. Obviously, we're gonna take into account that there's obviously either an affecting force or something like that to keep it in place, but now we have an extra horizontal value to deal with. That's kind of what I'm trying to inch at there. So now that we've defined what an inclined plane is and how to make a free body diagram, let's actually do one. So we're looking at here of a box that has a mass of 26 kilograms. It's sliding down a frictionless incline that makes an angle of 27 degrees with the horizontal. So with the horizontal just means off of like the horizontal plane, so starting at 0 degrees. And so draw the free body diagram showing all forces and resolve the gravitational force into its x and y components. So we can do that in the same step. So if we look at it here, and I just make this like this, we can take a look now. So my terrible drawing skills will be put to the test. So if I just draw like a triangle, you want to draw something that gives you a good amount of space to work with, so like that. Then obviously we have a 27 degree angle lift, I guess I could call it. I don't know exactly. But so let's draw our object. So our object needs to obviously be facing that way. We have a net force, obviously, going there. We have mg sine theta, and then obviously going this way we have mg cosine theta, and then being normal we have our mg just by itself, and it's just sliding down, so there's no friction. We don't have any force going against it, so that's something we can note. So that means that this way is positive if it's sliding downwards, so that's something we can take into account as well. So what we want to do is we want to find the value of the normal force. So obviously we have 27 kg as the mass of it. So if we're taking a look at this here, we're going to be finding the value of the normal force. So obviously normal force is just opposite of, or it's perpendicular to this variable, and we've already confirmed that mg cosine theta is the vertical value, or the vertical force against the inclined plane. So if we take a look at that, then that means that Fn is equal to mg cosine theta. That's something that we can confirm just by looking at kind of like with this free body diagram, or just kind of assuming based on any examples. So if we know that, that means we could have Fn is equal to 27, and the gravity is obviously 9.8, and that all that multiplied by cosine of 27, because our angle is 27. So that's kind of how that works, and it's exactly like that. So if you want, I'm going to give you guys a moment to do this on your own. You can like figure it out yourself, and then I'm going to explain the solution. Okay, and after that, now we're gonna take a look at this. So if we do this now, so obviously we're doing 27 times 9.8, right? We get about 264.6, and then you multiply that by cosine of 27, and we get 235.7. So oh no, 0.8. So 235.8 newtons is our normal force. So that's how we find our normal force. It's just kind of mg cosine theta and stuff like that. So now we're gonna find the acceleration of the box. So now what we're gonna have to do is since we've already found out this is positive, so we're gonna have this positive, means that with our sigma f is equal to ma. So if we look at that here, and we're finding this value, so that means that we're gonna have mg sine theta is equal to ma, or mg sine theta divided by m is equal to a. So now we know that, so we can start plugging in our values. So mg, obviously we know is 27 times 9.8. So if we just do that, and then that's all multiplied by sine of 27 instead of cosine, and then all that is going to be over 27. So now if we just do the math here, and so obviously we know that 264.6 is mg, and then we multiply that by sine of 27. We get about a 120. So then once you divide that value by 27, we should find that our acceleration is about 4.45 meters per second squared. So yeah, that's it realistically. Doing an inclined plane, most of the examples are going to be like this. Sure, you might have a value, like an actual force value, like we have it in our little example bit here, you can see. But realistically, you're not going to see too many of these. You'll see that more often than not. You'll see more often where you'll have an angle. So if I look over here, let's say if we have a force value that's like this, and that's our F, and that's our F right there, you'd see mostly that with like a theta here, something like that, and then you'd have to split it into its components. So that's obviously y of that, or Fy, and then this is Fx, stuff like that, and then you'd have to solve it. That's what a lot of examples would be, but this is kind of just like the base, and that's kind of it realistically. Otherwise, if you wanted to find values like this, all you have to do is just figure out what's your positive according to what the problem is, or finding out which of these values is larger. So yeah, that's really it. I hope you guys kind of learned something, obviously, because it's a newer topic with inclines and stuff. It's kind of like old forces, just now we have to deal with theta more. And yeah, I hope you guys enjoyed as well, and I'll see you guys in the next one. Goodbye.